It's a question from science fiction or the dream of a mad architect. Can we build a staircase to space? Not a rocket or shuttle, but a massive continuous structure stretching from Earth into space. Is it possible, or would it collapse under its own weight? To reach orbit, you must overcome Earth's gravity, or, more precisely, move sideways fast enough that as you fall, you miss the Earth. That's orbital velocity, about 28,000 kilometers per hour. Rockets do this by brute force, but what if we could just climb? The staircase isn't literal steps, but more like an elevator or cable, a space elevator. The idea is simple but incredibly difficult. Picture a cable thousands of kilometers long, tethered to the equator, extending beyond geostationary orbit, about 35,786 kilometers, balanced by a heavy mass, possibly an asteroid. Earth's rotation pulls the cable taut, letting climbers or robotic elevators ascend it using electricity or solar power, no fuel needed. On paper, it sounds elegant. The energy costs could be 100 times less than rockets. It would revolutionize space travel, satellites, cargo, even people could be sent routinely, safely, and with little environmental impact. So, why hasn't it been built? The answer is simple and crushing: materials. The forces on the cable are immense: gravity, tension, vibrations, wind, micrometeoroids. No material we have can handle it. Steel is too heavy, Kevlar not strong enough. Carbon nanotubes are perfect in theory, lightweight and hundreds of times stronger than steel. But we can't produce them in needed lengths and amounts. Still, progress is being made. Researchers in Japan, the US, and China work with graphene and other super strong fibers. The Climber, a robotic vehicle, would inch up the cable, possibly powered by lasers or solar panels, carrying cargo for a fraction of today's cost. Other challenges remain: weather, storms, space debris. Imagine space junk hitting the cable at orbital speed. It could slice through like paper. The cable must be anchored on a politically and geologically stable equatorial region, with constant monitoring and maintenance. Assuming we solve the material problem, invent a carbon-based fiber light and strong enough, produce thousands of kilometers of unbroken thread, anchor the base on a floating platform in the Pacific at the equator that can dodge storms, and balance it with a counterweight tens of thousands of kilometers above Earth. Then what? We would have created the greatest engineering marvel in history, a real tower to the stars. From it, missions to the Moon, Mars, and beyond could launch. Permanent orbital stations could be built. Large-scale construction in orbit, factories, habitats, solar farms would be possible. But the implications go beyond science. Whoever controls the elevator controls access to space. If the cable snapped, it wouldn't fall straight down, but whip around the planet, causing unimaginable damage. The risks are real and terrifying, yet the dream persists, not because it's easy or cheap, but because it means more. A stairway to space isn't just climbing up, it's reaching out, extending human imagination and ingenuity. It turns myths, Jacob's Ladder, the Tower of Babel, into technology. So, can we build a staircase to space? Not today, maybe not tomorrow, but history shows the impossible often becomes real with time, tenacity, and vision. One day, humanity might take its first real step, not just toward the stars, but up to them.